Welcome to my channel. Your tutor Mariam is here. It's a 58th video of Introductory Physics 1 and the 20th video I'm going to talk about the laws of motion. That is a fifth subject of Introductory Physics 1. In this video I'm going to solve an example about the net force. So you're going to see this type of problems a lot in your homeworks exam. So it's like two blocks attached to each other and they moves together. You need to find the net force and the force applied to each blocks. If you are new to Introductory Physics 1 and like to learn more, hit the subscribe button and like for more. You ready? Let's get started. So here I have two blocks with a mass of m1 and m2, and force F applies to blocks with a mass of m1. So first I need to find the magnitude of the acceleration of the system, and the second I need to find the magnitude of the contact force between two blocks. Let's see how can I approach this problem. For the first part, I need to find the magnitude of acceleration of the system, right? So the trick here, I'm gonna assume m1 and m2 is like a one blocks. So let's consider it as m here. Now let me write down the second Newton's law. Based on the second Newton's law, F total gonna be m times a, right? Acceleration. So my m here gonna be m1 plus m2, right? Because if I move the box, they both gonna move together, right? So that's gonna be m1 plus m2 and a acceleration. That a gonna be the acceleration of the system, like the acceleration of m1 and m2 together, not separately. So here my F total is gonna be equal to little f. The reason I'm saying that is when the force F applied to the system, blocks gonna move, right? And of course they move together. So my F total gonna be equal to F, right? There is no other forces applied to this system. So my answer for part A gonna be this. It's gonna be a times m1 plus m2. And if I like to find the acceleration, then my acceleration gonna be f divided by m1 plus m2. That's gonna be my total acceleration. For part B, I need to find the magnitude of the contact force between two blocks. Let me break down these two blocks. So for m1, what I have, that's gonna be my m1. Force F gonna be applied to m1, and also m2 gonna be apply another force to m1, right? And that force gonna be in the opposite direction. So I'm gonna call it as F21. Force that blocks 2 apply to blocks 1. That's why I call it as F21. So let's think about it. I'm gonna move the box. M1 gonna move, right? Now M2 is attached to M1, right? So if I want to move the box in the right direction, M2 doesn't want to allow me to move M1, right? So it's like kind of the friction force. If you think about it, that's not a friction force, but just give you an idea how that force gonna work. So this is like I'm trying to move the blocks with a mass of m1, but m2 behaves as a barrier or obstacle, and it doesn't want me to move m1. So it's apply the force in the opposite direction to m1. But how about m2? Let's say I have m2 here. This is gonna be my m2, and there is one force applying to m2, and that force gonna be in this direction. So it's gonna be F12. the force applying from 1 to object 2, right? Again, think about it. These two blocks attach to each other, right? If I try to move M1, I also move M2, right? Because they both contact to each other. So if I move M1, M2 also moves, and the force is gonna be F12, right? And of course, F21 equal to F12, right? Think about the third Newton's law. These forces gonna be equal, but they have an opposite direction. Okay, that's the third Newton's law that I explained in the previous video, and I'm gonna put the link below. Let's go back to the part B. Find the magnitude of the contact force between two blocks. Let's start with M1. So for M1, what I have F as positive, right? Minus F21 M1 times acceleration, right? From the previous slide, I found the acceleration, so that's gonna be F divided by M1 plus M2, right? So my point here is finding F21, correct? So that's gonna be F minus M1 F divided by M1 plus M2, right? So I can take the F out, is gonna be 1 minus M1 plus M2, right? And if I do the little math, then my F21 gonna be equal to F, so it's gonna be equal to M1 plus M2, M1, M2 minus M1, right? That M1 cancel out. So my F12 or 21 gonna be equal to M2 divided by M1 minus plus M2. And that's gonna be my answer for F21. Based on the third Newton's law, my F21 and F12 should be equal, right? But let me calculate it for M2. So again, for M2, what I have is F12 gonna be equal to M2 times acceleration, right? And that's gonna be the total acceleration that I found it in the first slide. So it's gonna be F divided by M1 plus M2, correct? And this is gonna be the same answer I found for F21. As I said in the beginning of the video, you're gonna see these problems a lot in your homeworks exam in the Introductory Physics 1. So I decided to explain it with the parametric values. I hope you find this video helpful. If you like my video, hit the like button, and I'll see you in the next video.